So we're back to calculus today. I want to get to the beginning of where it all starts. It starts with limits. That's where it starts with. Calculus starts with the idea of a limit, period, point blank. The textbooks give crazy definitions. They do make sense, but it's best to kind of talk about it in common sense terms before you understand what the formal way of defining things are. And I guess my common sense definition, that technical definition, that textbook definition, common sense definition is a limit is basically nothing more than what the height is that you intend to reach. That's it. First example, I have a function is equal to x plus 1. My question to you is, what happens as x gets closer to, let's say we get closer to the number 3? What's my intended height? That's a super simple answer, because if x is getting closer to 3, let's see what happens when I plug in a 3. Look like the answer is 4. Therefore, the limit as x approaches 3 of x plus 1 is equal to 4. The limit is 4 because when we plugged in, we found out our answer is 4. It intends to reach a 4. So if I'm cruising along this x-axis and I'm getting to the number 3, this is where I'm approaching. I'm approaching 3. If I stop on 3 and take a look around, that's my intended height right there, 4. Almost every function that you've been dealing with in mathematics until you get to maybe pre-cal and calculus, for the most part, almost every function you deal with is predictable. All you do is plug in a number and you have a limit. In calculus, we deal with them all. Predictable, unpredictable, weird stuff, jumping around, holes, all of that. So there's a way that we can figure out the limits, even though when you plug in numbers, your calculator may give you some type of error. Before I get to my next example, we're going to have to look at this one last time. All right. I'm approaching 3. I'm plugging in a 3. I hit enter. Look what happened. My limit is 4. So as I approach 3, my height is 4. Very important you lock that in, because something's about to happen with the next example. All right, don't get scared of this problem, all right? So now I have a new function. X squared minus 2x minus 3 divided by x minus 3. Question is, what is the limit as x approaches 3? All right, so I'm plugged in 3's everywhere there was an x, and now I have to calculate using the order operations. So I have 9 minus 6 minus 3 all over 0, which is basically 0 over 0. So 0 divided by 0 has no answer. We call that an indeterminate form. When that happens, that means there's something that you could do to the problem to get around it, all right? And that's where your algebra comes in. So what we know now is that x cannot be a 3 right now. If I use a 3, I get this. Does that make sense? X can't be 3 because this happens. So it's crazy. Like, we know we can't plug in a 3, but we still want to know the limit as we approach 3. So since this happens, we have to use some algebra and factor. Those cancel out. When those strike out or cancel out, or whatever term you like to use, my simplified version says this: the function of x is equal to x plus 1. But let's not forget, x cannot be 3, all right? So I simplified it. I have the function of x is equal to x plus 1. Let's not forget, x cannot be 3. I still want to plug in a 3. My answer becomes a 4. My limit as x approaches 3 of this function is 4. So I plugged in a 3 and got an indeterminate form. That means no matter what I do, if I plug it into a calculator, a computer, whatever the case may be, anytime I try to plug in a 3, it's never going to give me an answer. But that doesn't mean we can't find a limit. So back to the common sense definition of a limit. A limit is what you intend to reach, all right? That's what you intend to reach. It's very important you understand you intend to reach it, because that implies that you may not ever get there. I have it set in my calculator, the problem itself. This is what it looks like, right? So let me go to the number 3 and see what happens. See that? I plug in a 3 and look what happens there. It's an error. I want you to recall the first time I showed you that calculator problem, when I plugged in the 3, I got a 4. Second time we did the calculator problem, I plugged in the 3, it got an error. But those graphs looked pretty much exactly the same. A calculator is nothing but a tool, all right? Nothing but a tool. It has its limitations. It can never, and I repeat, it can never beat the human mind, all right? It cannot do it. So let's get to it. The first example, I plugged in a 3, the height was 4. The second example, I plugged in a 3, I got an error. That's where the hole is at. But look what it intends to reach. It still intends to reach a 4, even though there's a hole right there. If I had to send mail to this house, as I approach 3, the house is located at a 4. So at 3, 4, the mail would get there. You get what I'm saying? The mail can make it to that house. That's the location. That's the limit. Now, if you had to send mail here, the mail will intend to reach 4, right? But see, there was a gas leak at that house and it blew up, right? The limit is still 4, but we will never actually make it there. So a limit is the height that you intend to reach. Even though you never make it there, you can still intend to reach it, all right? So there's still examples where we will have limits that don't exist, but that's for another day. That's another lesson.